In this video, we're going to go over a concept of proportionality. It is such an important topic that is often not directly explained to students. And it is so important because it's one of the most foundational tools that allows us to understand physics equations and how changes in one variable can affect another variable. So firstly, we're going to discuss what does it mean for two variables to be directly and inversely proportional. Then we're going to learn the proportionality method, so seeing how changes in one variable affect another one quantitatively. So by the end of this video, you should come out with a really strong understanding that you can carry on throughout this whole year into this class. So let's firstly start by talking what is proportionality. So proportionality essentially describes how a relationship between two quantities where change in one results in predictable change in another one. Let me explain this a little bit further by firstly introducing two different types of proportionality. One that is directly proportional and another one that is inversely proportional. Let's examine these two equations right here. So y is equal to bx, right? X is going to be the input, the variable, and y will be the output. And b is just some kind of positive constant. So it could be like 2, 3, 4, etc., right? Just any positive number. So as I plug in different quantities for x, for example, 1x will give me y will be 1b. If I plug in 2 for x, y will be 2b. If I plug in 3, y will be 3b, etc. So as you can see, as x goes up, y also increases, right? Graphically, it will look something like this. It's just going to be a graph of a line, of a positive line. So we call this a linear relationship. A linear relationship, or directly proportional, is when one variable increases, the other variable will increase as well. So they have the same behavior. Similarly, right, if x would have decreased, y would have decreased as well. So directly proportional means essentially they have the same relationship. So as one goes up, another one goes up, or the other way around. What about the inversely proportional? So as you can guess, right, similarly, if b is a positive constant, this relationship will be opposite. Because here, as I plug in greater and greater values of x, so for example, 1 will be simply b, 2 will be b over 2, 3 will be b over 3. So as you can see, 1 over 2, 1 over 3, 1 over 4, right? Our numbers are actually decreasing, right? So as x goes up, y goes down. Or if I decrease the x, y would actually go up. So this what it means for them to have an inverse relationship. As I increase one variable, right, the other one goes down. Just I also want you to keep in mind, right, that this equation will be the same if I multiply both sides by x. I can also write it as xy is equal to b. So when you analyze the equations, right, you see both variables on the same side, it's inversely proportional as well, right? Or so if one variable is at the top and another one is at the bottom, so that's also inversely proportional. It's just two different forms of writing the same thing. Now, let's take a look at some quantitative problems, right? So over here, we have the same equations we see on the previous page. And I ask you a question. If I increase x by the factor of 2, by what factor does y change? So it might be a pretty easy problem, right? Of course, if I make x twice as big, y will become twice as big as well. But I want to introduce another example with this. So instead of y is equal to bx, I can write this equation as y is proportional to x. This right here is a proportionality sign. What it allows me to do is, if I don't change any other variables in the equation except x, right, what I can do is simply drop them and just write x here. So this sign doesn't mean that y is strictly equal to x, right? It just means it's proportional to x. What it allows me to do is a lot of cool mathematical calculation. So for example, I can literally just plug in the factor by which x changes, so 2 for x, and I can get that y also changes by 2. Now, let's take a look. Let's take this concept and apply it to this next problem right here. Right here, given this equation now that we also saw on the previous page, if I increase x by the factor of 3, by what factor does y change? So firstly, let's write this as proportionality. So that means that I'll write proportional sign and I will just write the variable x. but x is in the bottom, right? So it's going to be 1 over x. So y is proportional to 1 over x. If I plug in the factor by which x changes, I will get the factor by which y changes. So x changes by a factor of 3. So just like this, I got that y will change by a factor of 1/3. So as you can see, it's a pretty useful method, right, to answer these types of questions. Like if I change this number by this factor, by how much this other variable changes. Great. Let's take a look at some more complicated examples. So given now this equation, y is equal to bx squared plus c, where b and c are just some constants, if I increase x by a factor of 5, by what factor does y changes? So again, first, if we have this type of question, what we can do is we can rewrite this equation as using our new sign of proportionality. So we're going to rewrite it without the constants b and c. So just write it as x squared. So in other words, right, y is proportional to x squared, right? Remember, it's not only can you have directly proportional to x, right? It can also be proportional to x squared. Anyway, now that we rewrote this, let's plug in 5 for x. So we get that y changes by a factor of 25. Great. Now, let's take a look at the next example. So given this equation that a is equal to v squared over r, if I increase v by a factor of 3, by what factor does variable a changes, right? So by what factor does a changes? Now, it doesn't really matter what this equation mean, right? I just wanted to introduce equation where it's not simply y and x, right? But we can rewrite it in the same, using the same method that we did before. So a is proportional to what? It's proportional to v squared, right? We basically are dropping the thing that is constant, which is r in this case. So if v changes by 3, a variable a will change by a factor of 9. So just like before, I rewrote this equation using proportionality sign, right, and just drop the stuff that stays constant. Now let's take a look at this final problem right here, probably the more challenging one, right? We have an equation for force of gravity that you will learn a lot later in the year, and these two questions. So this is the equation itself. So g is just going to be a constant, m1 and m2 are two masses, and d squared, d is like the distance between the two masses. The question is the following: if I increase m1 by 10, by what factor does f change? So in this first example, everything else stays the same except m1. So therefore, I can rewrite f is proportional, right? If I just basically keep everything the same except m1, is going to be proportional to m1, and I can drop everything else. Then if m1 increases by 10, I plug this in, I plug 10 for m1, so f will also change by 10. In other words, f and mass, right, the force and the mass, are directly proportional. So if I increase this by 10, this will go up by 10 as well. Remember, when I answer these questions, I don't have to care about all these other variables that basically remain constant. Now, in the second question, I increase, what I meant to say here, if I increase d by a factor of 10. So if I increase the distance. So now everything stays the same except distance. So I can rewrite this equation as proportionality. So basically taking these variables out. So it's going to be f proportional to 1 over distance squared. Now we're plugging in 10 for a factor of distance. So therefore 10 squared will be 100. So if I increase d by a factor of 10, my f will change by a factor of 1 over 100, right? Great. So hopefully this was a really useful review and a really useful lesson on proportionality. Please feel free to practice these problems by yourself again and see, especially this last one, and see if you can answer these questions by yourself. As always, keep watching these videos and keep practicing. As in the next video, we're going to learn about also a very important topic of vectors. So thank you guys for watching. As always, keep practicing on your way to an A.